Welcome to Math with John, Natural Number Arithmetic, Lesson 2, Exponents. Repeated multiplication is such an important topic in mathematics that a special notation has been created just to deal with it. Let x be a natural number. Note that these rules work for x being just about any other number as well. Let n be a positive integer. Define x to the n to be equal to x multiplied by itself n times. X to the 1 is just x. X to the 2 is x squared, which is x times x. X to the 3 is x cubed, which is x times x times x. And x to the 10 is x multiplied by itself 10 times. I double check to make sure that there really are 10 x's on the screen. Perfect squares are positive integers that are equal to x squared of some positive integer and the number 0. The first 10 positive perfect squares are listed here. This is a list of other powers that have small answers. Exponentiation can lead to some very large values. For example, 7 and 10 are reasonably small numbers, yet 7 to the 10th power equals to a number greater than 5 million. The equations listed here pretty much cover most of what you need for learning how powers work. Memorizing the equations and answers in the last two slides can be quite helpful. Inverse of raising to a power. The function of raising a number to a power when the exponent is a positive integer is defined by repeated multiplication and has an inverse. The x squared, if x squared is equal to y, then the inverse of this is to say that the square root of y is x. Same for x to the third power, where x cubed equal to y means that the cube root of y equals to x. This applies to any power of x, and you can see the notation that is used for various roots. Note, raising a number to a positive integer power has only one possible answer. 2 squared is 4 and nothing else. The square root of 4 is 2, but when you include negative numbers, the square root of 4 can also be negative 2. This is a list of assorted roots. Note that 64, which equals to 2 to the 6th, is also equal to 4 cubed and 8 squared. Similarly, 81 is equal to 9 squared and 3 to the 4th. Note that if you memorize a power equation, like 11 squared is equal to 121, then you are also memorizing a root equation. Root 121 is equal to 11. Two important exponent rules. Rules 1 and 2 are easier to read than to say and pronounce. Here goes anyways. Rule 1 is that x to a power times x to another power, or the same power for that matter, equals to x to the sum of these powers. Rule 2 is that x to a power, all raised to another power, equals to x to the product of those powers. The x squared times x cubed set of equations demonstrates that x to the n times x to the m equals 2 x to the sum of n plus m. The product of two x's and the product of three x's get merged into one big product of all the x's in one place. That's the definition of addition. No different from having two apples in one bag and three apples in another. If you combine them into one bag, then you have 5 apples. The Rule 2 set equations demonstrate that when taking a power n to a power m, and m can equal to n, it's like having n chunks of products with each chunk having exactly n products. This is multiplication. It's like having 3 different bags of apples, each with 2 apples in them. Combine them all in one bag to get 3 times 2 equal to 6 apples. Finally, if I am carrying 3 bags of apples with 2 apples in each bag, and you have 2 bags of apples with 3 apples in them, then we both have 6 apples. So for the set of equations, 64 is equal to 4 times 4 times 4. By definition, that's 4 cubed. And 4 is equal to 2 squared. Now here is where Rule 2 is applied twice in 4 steps, backwards and forwards. 2 squared, all cubed, equals 2. 2 cubed, all squared. After that, 2 cubed equals to 8, and 8 squared is equal to 64. Additional details. The first additional detail is just another way of saying that multiplication is commutative. X plus y equal to y plus x. But the idea behind that equation is the same idea that drives the second additional detail. This states that if you have x to a power n, all to another power m, then you can either solve the problem in the given order, first taking x to the n power, or you can multiply the 2 powers first and then take x to the n times m power, or you can first take x to the m power. Different choices apply to different problems. Test your memory. Test problems. Go over these problems until you can do them from memory. Do them forwards and backwards. Add other problems and make up your own tests. This is one of many possible ways to memorize as many mathematical facts as you can. Building up your memory to learn math also builds your memory and helps make it easier to memorize facts about other things. And here are the answers. The only problem that requires any discussion is the cube root of 64. 64 is equal to 4 cubed, and the cube root is the inverse of cubing. So the cube root of 4 cubed is just 4. Thank you for listening. Please like and subscribe.